Assalamualaikum and very good day to my panel. My name is Muhammad Akmal Ridzuan and I'm student of Mechanical from College of Engineering at UiTM Shah Alam. So for today, I will present to you about my final year project with the title Design of Adjustable Funnel and Stem for KARAKURI Assembly Line. Before continue, for this project, my supervisor is IR Dr. Noazlina binti Muhammad Saleh. First of all, I would like to thank her for helping and guide me in making this project. With help of some tips and knowledge, I able to complete this task. Thank you very much. From this presentation, this is a content that we will go through this slide. The content lists are introduction, project methodology, result and discussion, objective, scope work, and conclusion. Okay, next. I will tell a little bit about a background for my project. Basically, my project was originally applied from KARAKURI assembly line concept, means that KARAKURI system is using gravity concept. The concept applied means that the line of the assembly will start at a high position to low position. In addition, this project was conducted with cooperation of MARI, Malaysian Automotive Robotic and IoT Institute. So, the product that being used in this assembly line is MARI stationary phone holder. I will show those products in other slide. Then for this assembly line, smart manufacturing was applied as the assembly product line is fully automated. The device use only mechanical gadget, shun electric, hydraulic or pneumatic power. Therefore, for my project, I will design inventory funnel and stem for this assembly line. We continue with next slide, problem statement that we detect during conduct this project. Firstly, the flow of the product to assembly line from inventory box to inventory packaging box as the line was fully automated. Next is the design of inventory funnel and stamping. We must make sure the criteria that need to be used so the design are suitable and fit with the criteria for whole assembly line. Next, type of material used. The material chosen must be safe from giving damage to product and also must be light and durable so it can be easily mounted to the assembly line. The objective and scope work in this project were listed as in the slide. The objectives were to study the mechanism of KARAKURI assembly line, to design the funnel and stamping process mechanism, and do simulation and analyze the design using Blender software. And for scope of work, the goal of this project is to construct a low-cost, high-efficiency assembly line. Next is to the design of inventory line session. The first session with funnel and stamping process, and the software used to design is CAD software CATIA V5R20. We continue with project methodology. The method used is the MADV method, which are define, measure, analyze, design, and verify. Before we continue, we gather some information so we clearly understand the mechanism and process for this project. From the information, this assembly line was developed to flow and assemble the product called stationary phone holder (MARII) to KARAKURI system application. The first methodology is defined. The project was to develop a low-cost inventory KARAKURI management system. In this project, design of funnel and stamping were constructed so it can help the flow of product, which is MARI stationary holder, to assembly line. A product design specification is a file created at some point of the problem definition, pastime, and early degree of layout manner. It describes the requirements that have to be met for a product to achieve success. Therefore, product design specifications were conducted for both funnel and stamping. For both design specification of funnel and stamping, the material used were acrylite and aluminium as those materials were suitable and safe to use. The size and dimension for both design must follow and suit the size of the product. The next is a measure. To begin the designing process of inventory funnel, brainstorming sessions were conducted to benefit and concept on what the specification needed. From the ideas benefit, a morphological chart is generated on table below. So as you can see in the morphological chart, the material used for inventory funnel is acrylic, and the mechanism of the funnel is mass adjustable. It can be adjustable and fixed. And for the funnel flow, it will flow a top and bottom part of the product, and the funnel will be attached with the inventory box which hold the top and bottom part of the product. In addition, to apply a concept of Karakuri and relate it in this project, the concept design was proposed to experts to gain their view and opinion whether the design suitable or not in the material used. Figure below show is the concept design for stamping process, adjustable funnel, and fixed funnel. Inventory box for bottom part product adjustable funnel. There were three design concepts created, which are concept design 1, concept design 2, and concept design 3. Okay, next is analyze method. The inventory Karakuri funnel and stamping management system process is examined during the analysis phase. The first step is to deconstruct each process in the inventory Karakuri management system. The inventory Karakuri management system process is examined during the analysis phase. To show the mechanism of the system, the illustration of the process is shown in the figure below. From the illustration, the bottom and top part flow from inventory station to funnel. Then both bottom part product will flow to assembly line to the next station, stamping station. At those stations, the stamp will stamp the product so both parts will attach properly. This is a view chart. A view chart for adjustable funnel was constructed to compare the design concept. The design which met the criteria was chosen. Based on the view chart below, design concept 2 was chosen as a final design for this project. The next is for design methodology. The software used for design of inventory funnel and stamping is CATIA V5 software. Then the simulation for the mechanism work will be used Blender software. For funnel, the design was divided into two, which are inventory box for bottom part product adjustable funnel and inventory box for top part product fixed funnel. For top part product, the funnel design was fixed as the design of the inventory box was fixed into one position, which is vertical position. Meanwhile, for the bottom part product, the funnel design was adjustable as the design of inventory box was flexible as it can change position of the product whether horizontal or vertical. For a stamp design, stamp was designed so the bottom part and top part of the product was attached perfectly and the bottom and top part of the product flow from the inventory box then to inventory funnel to assembly line. Okay, last but not least, a last methodology is verify. This phase is critical in determining how product parts are released and moved. The main theory used for dynamic analysis is Newton's second law of motion. The following is the formula: F equal to ma. These formulas are used to investigate the kinematic motion of the product as it moves from the inventory box and funnel to the assembly line. This calculation can also be used to compute the inventory system cycle time. For stamping, the formula will be used to calculate the force needed to move the stamp when the product reaches the stamping process line. After following the DMADB methodology, the result and discussion achieved was listed as shown below with the design of inventory box with funnel for top part of the product, design of inventory box with funnel for bottom part of the product, and design of stamp station. Then the simulation was done to show the mechanism work for those designs. Okay, next is a cycle time. For the cycle time analysis, the time that is assumed for the product release from inventory box to funnel for both top and bottom part is 2 seconds. Therefore, dynamic analysis was done and the results are shown below. For a cycle time for bottom part and top part, it shows a same time, which is 2 0.37 seconds. Pusher-release mechanism was also applied to stamping process. The force produced by a pusher needed to push the stamp to touch a top part of the product, so it will attach properly with bottom part of the product. Based on calculation analysis, the force needed was at 0.892 Newton at angle position and 1.03 Newton at vertical position of the stamp. Next table shows a costing estimation in conducting this product. From the table, we can see that the cost estimate is at about Rm 434 and 92 cents. Next is a simulation part. To show the mechanism and process of the design of inventory funnel and stamping process, the simulation was done by using Blender software animation. The simulation was done with two types of simulation, which are simulation of funnel and stamping with vertical position of the product and simulation of funnel and stamping with horizontal position of the product. Those are the video simulation for inventory funnel and stamping for vertical and horizontal position of the product. I will start with the simulation which bottom part of the product was at horizontal position. From the video simulation, we can see that the bottom part will flow to the funnel and then to assembly line. When the bottom part reach the stamping station, the top part will go to a funnel and meet the bottom part. After that, the stamp will stamp the product, so the bottom, top and top part will attach properly. The same concept was also applied when the bottom part of the product was in a vertical position. Detailed simulation for adjustable funnel. From the picture show, we can see the difference before the funnel was adjusted and after the funnel was adjusted. The simulation of the mechanism was shown in the next slide. This is how the mechanism of the funnel before and after adjusts. The funnel can be adjusted due to change position of the product. Last but not least, at conclusion. From this project, the funnel and stamping design part were designed by using CATIA Viva software, and the mechanism work for those design was shown by simulation using Blender software. The dynamic analysis turned into perform to determine the anticipated cycle time for the technique from stock fill to the assembly line, and also the selection of launch mechanism. KARAKURI Kaizen is applied to this project that use gravitational force to move object from one station to another station. Even though the KARAKURI Kaizen especially make use of gravitational force as its important supply of electricity. However, this task is specializing in addition of net of factors. We are applying a motor to rotate assembly line and a sensor to detect the prevailing of component at each station. Therefore, to obtain a whole automation device, digital component is deliberate to be introduced to the machine to manipulate the characteristics of the system. For the simulation, Blender software was used. From the simulation, the mechanism for both designs were successfully done. Therefore, the objective has been achieved. I think that's it for my presentation for my FYP2 project. For any inquiry, the contact can be met through my Gmail and phone number given in the slide. That's all for me. Once again, thank you to my supervisor and panel.